So for problem 7, it states find the limit of as x approaches 0 of 5 times tan of x over 4x. So here's how I solve this problem. There's a couple of things I'm going to use. I'm going to use properties of limits, and I'm going to rewrite tangent. Okay. So first of all, the one property of limit that I'm going to use there is the property where you could pull out constant multiples. The constant multiple that I'm pulling out is not just 5, but rather 5 over 4. So this limit is the same thing as saying 5 over 4 times the limit as x approaches 0 of tan of x over x. Now, tan of x is the same thing as sine over cosine, right? Tan of x, if you recall, is the same thing as sine over cosine. So what you can do here is when you rewrite tan of x, then you will technically have a fraction in the numerator. That fraction is sine over cosine, but informally, you could just stick the cosine in the bottom. So if you do that, you get 5 over 4 times the limit as x approaches 0 of sine of x over x times cosine of x. Okay. So again, imagine that you're replacing tan of x with sine over cosine, because this numerator now will contain the cosine of x, right, a complex fraction. Just stick the cosine of x into the bottom. Now, I'm going to use one more property for limits. What I'm going to do is split this into 2 limits now. The way that I'm going to split this into 2 limits is that when I look at this, I should recognize one of this inside of the first limit here. We have a special limit. That special limit is sine over sine over x, right? So you're going to have 5 over 4 times the limit as x approaches 0 of sine of x over x times the limit as x approaches 0 of 1 over cosine of x. Well, now we're ready to solve. We have 5 over 4. This is a special limit here. This is going to go to 1. As x approaches 0, cosine of 0 is 1. So 1 over 1 is 1. Multiply the 3 numbers, you get 5 over 4, and you can call it a day.